Hey guys, Forex here. Hope you're all well. What you're looking at in front of you is a massive Amstrad CPC 464. It's that big I can't even get in shot. Yeah, but this thing's not working, guys. And I think I know what the problem is. I think the gate array has failed in this system, and I'll show you why. If I power on the system, you can see we've got power, and if I fast forward the actual tape deck, maybe you can hear that. So that tells me the system's getting power, but if you look at my TV, I'm getting no image. Now generally on a TV will not display an image like this unless it can lock onto a sync signal. So you know, it doesn't matter if you're sending RGB over the SCART, if the sync signal is not being sent there, it's just not going to lock on and display an image. So this is a different type of problem to, say, a black image. When you get a black image, you at least know the system is partially working, while you know the video encoder is doing something, because you're getting a black screen. Where with this, it's not displaying anything. And if you know anything about these Amstrad CPCs, inside them there is a gate array in it, and if that thing goes, yeah, it's good night system. Yeah, we'll get inside, guys, we'll have a look, but yeah, I think the gate array's busted in this thing and I might have to replace it. Now, to get in the Amstrad CPC, it's actually very easy. There are 6 screws you have to remove. There's one here, 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 and the final one is here. Remove those and then I'll show you how you take the top of the lid off. Now, to get in the Amstrad CPC 464, it's very much like a Spectrum Plus 2. You grab it, there's the tape deck like this, you lift it up, and the first thing you'll see, if I get under there, you'll see an actual cable here that plugs into this connector. This is the tape deck and the power and speaker wires that plug into this connector here, so just remove that. What you need to do then is open it up like a clam. Now, depending on your revision of Amstrad CPC, just remove that there. You will either have a connector like this that plugs into the keyboard just there, or it plugs into the motherboard, or you'll have a membrane that plugs into the tails plug into 2 connectors. It's very simple, just remove the connectors and you should be able to take the top lid off. So I'm going to remove that connector just there, and then I can get the top lid off. Time to get the motherboard out. Now that's not difficult, it's just a series of screws we need to remove. Now thankfully Amstrad put squares around the screws and you can see them. There's one here, 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 and the final one is here. Remove those screws and you'll be able to just pull the motherboard straight out. Now, I forgot all about this, guys. You can't turn this system on when it's like this. You need a switch that plugs into this header to switch it on, and when you take the top lid off, you take the switch with it. So what I've done is I've just made up a little switch harness that plugs into this connector here, so I can switch the system on. That's my switch installed, so I can turn it on and off. Now this system just runs on 5 volts. It doesn't generate any other voltage rails, it just takes 5 volts coming in and uses the 5 volts. Now what I've done is I've hooked up a negative lead and a positive lead across this bypass capacitor, and when I switch on the power, hopefully we see 5 volts, and that'll tell me if the voltage rails are fine. Yep, and there you go, dead nuts on 5 volts. So that tells me that the system is getting voltage across the board okay. what I'm going to do now is I'm going to fire up the big boy. I'm going to fire up my scope, and I'm going to start looking at signals, you know, reset, clock, interrupts, all those type of signals, because it wouldn't surprise me if a lot of those are screwed, especially if the gate array's failed, the gate array's under this chip. A lot of those signals are going to be screwed up if it's failed. So yeah, I'm going to fire up my scope. I'll start looking through those signals, and if I find anything, I'll come back and show you. And I've definitely found something sketchy. If we take a look at the CPU just here, this is Z18, this is the main CPU for the Amstrad CPC 464. If we look at pin 6, that is the clock signal, so let's count them. 1, 2, 3, 4, 5 and 6 is just here. If we take a look at that signal on my scope, you can see it's totally flatlined. There's no clock signal there whatsoever. Now the clock comes from the gate array, which is under this heatsink, and it is derived from this crystal. Now if we take a look at this crystal just here, if we look at its output, we can see it is actually oscillating. You can see that. Now also what I found as well is the output of the clock to the gate array is this connector just here. This goes to the gate array, and then the gate array generates all the clocks. So if we take a look at that signal, you can see, if I just remove my probe a bit, I'll take it off and then put it back on again. There, you can see that is pegged high all the time. So we might have dodged the bullet here, guys. This might not be the gate array, that's the problem. I think there's something happening in the clock generation circuit here, and it's killing the clock that's going to the gate array, and obviously that can't generate other signals. So yeah, what I'm going to do now is I'm going to spend another 10 minutes just reverse engineering the clock just here, and I'll see if I can find what the problem is. Got some good news. I found the problem. This 7400 chip just here is busted. One of its gates has failed. Now they're using this chip to buffer the actual crystal, and they're using it to generate a better, more square wave type signal for the gate array when it comes to its clock. Now let me show you the pin out. Now the 00, as you can see, is 7400, is a NAND gate, but they've used it weird in this circuit. Now I don't know why they've done this. Pretty much what they've done is they've tied both the inputs on each gate together, and when you do that with a NAND gate, you basically turn it into a hex inverter. So if we look at the truth table, if A is low, it doesn't matter what B is, the output is high, right? And vice versa. The only time it changes is if both inputs are high, then the output is low. So pretty much, like I said, what they've done is they've tied these two inputs together on each gate, and they've created an X inverter. And the truth table for that is, if the input is high, the output is low, and vice versa. If the input is low, the output is high. Now what I'm going to do now is I'm just going to set up my scope again, and I'll show you the problem with this 7400. Let me show you what the problem with this 7400 is. If we take a look, remember when I said both the inputs to the gates are tied together? So these two are tied together. So here's an input, and I'll show you that on my scope. That's one input, and if you look at the second input, they look identical, and that's because both the inputs are tied together. Now if we look at the output, we should get a signal, because obviously all it's doing is acting as an X inverter, and as you can see, there's the output. Now if we go to the next gate, same again, both the inputs are tied together, so I only have to look at one of them. So if we look at the input here, and we look, we can see we've got a signal there. Now if we go again and we look at the output to this gate, remember it's just acting as an hex inverter, we should get something on the output, and we do. There we go, as you can see. Now if we look at the next gate, here's one of the inputs. Remember, these are tied together, and there you go, there's a signal. Now if we take a look at the output of that gate, what do we get? We get absolutely nothing. So yeah, one of the gates has failed in this, guys, because you know, if this is acting as an X inverter, and we can see is the input, right, we should definitely be getting something on the output. And if we look at its output of this gate, we're just getting flatlined. So yeah, one of the gates has failed inside this 7400. So yeah, let's get this thing out and replace it. That's the chip removed. Let's get a socket on there and put a new chip in there. So I've digged out some 7400 series logic chips. I've only got the S version. I'd rather put an LS version in there, but oh well, I'll put one of those in and then give the system a test. As you can see, new 7400 is in there. Let's power on and see what we get. Oh, hey, hey, you beauty! Son of a... Wow. So yeah, there was nothing wrong with the gate array. This chip was busted. Son of a... I'm so happy now, guys. Look at that, we got it. Yeah, get in there. Winner, winner, chicken dinner. Yeah. Okay, guys, what I'm going to do now is I'm going to fire up my scope, because I want to see what the clock looks like once it's been processed through the actual 7400 before, when it's coming out the actual crystal, and then when it's going to the gate array. I just want to have a look and see what it looks like. I'm just interested. Yeah, that's a winner right there, guys. Get in there. So what I've done, guys, is I've got my TL866 mini programmer out. You can see it just there. I've got the logic chip in there. Now you may not know this, but if you have a TL866, you can actually test logic with it, and as you can see, I've already gone ahead and done it, and now set the 7400. So let's test it, and there we go, test error, logic unit 4 test error. So that's confirmation, logic gate 4 in this has failed, and that's what was causing our problem. I can show you better now on the schematic what the problem was. If we take a look at this area, this is our 7400. These are the gates inside the 7400. Here's our crystal, 16 megahertz, and yeah, as you can see, this gate had failed. Now if you look, when I turned around and said that they're using these NAND gates, these are NAND gates, and they're converting them into hex inverters. You can see that because if you can see they've tied the input on each gate together. You can see that there. Look, they're all tied together. So, like an X inverter, if this is low, the output is high, and vice versa. If the input is high, the output is low. And you can see what's happened here. This gate's fine, this gate's fine, this one's failed, and then you get the cascade where the system has especially the gate array is not getting the clock, and that would make perfect sense now why we were seeing no video coming out of this thing, because obviously the gate array needs a clock that distributes the clock around the system. You can see it here. This is the clock to the CPU going here. So yeah, that was the problem. Gate 4, I think, yeah, it's gate 4. Gate 4 has failed, and we get that cascade effect which affects the rest of the system. I fired up my scope. It's still going. Please don't blow up now. So yeah, the first thing I want to look at is the crystal. See it oscillating, and there you can see it on my scope. It looks more like a sine wave. Now if we look at the output of this, which goes to the gate array, which was missing before, take a look. What you'll see is it looks more square, and it's also TTL logic level as well, and that's why they're processing the clock through all these gates. Now if we look at the clock for the CPU, which is pin 6, is 1, 2, 3, 4, 5, 6. There's the clock for the CPU. So yeah, looks like we've got this one working again, guys. What I'm going to do is get everything back together. We'll see if we can load a game. Let's see if we can load a game from tape. So yeah, let's get it all back together again. We're all back together, as you can see. Thankfully it's still working. Now I've been testing this off camera, and I can confirm the keyboard works 100%, and surprisingly enough the actual tape deck actually works as well. But I will be reconditioning it because I don't know how old the belts are in this thing. So yeah, I'm gonna pop a game in, Guerrilla War, and we'll load it. So let's shut the lid. Now to load the CPC, it's very easy. You press Control, Enter, Enter, and you get the press play on tape. So I'll go ahead and do that, and it should load the game. Now one thing I've noticed about this CPC is how good a condition it's in. None of the keys have really faded, and it looks really clean, which tells me that this probably broke down pretty early in its life, and someone just put it in a box and stored it in the loft. You can see it's actually loading the game. It's farm block 1. Yeah, so they just stored it in a loft in a box, and that's why it's not so dirty. It does have that lofty smell to it though, but yeah, it's working. But I'm definitely going to recondition the drive anyway, the tape deck, sorry. But what I'll do is I'll let this load now, and then come back once it's done. Just come back really quick, because if we take a look, we get in the image drawer. Okay, yeah, I'll let this finish loading, guys, and then come back. So did it load? You can probably hear it did. Yeah, it loaded perfectly fine, guys. Now, even though the tape deck's working, I'm going to order some new belts now, and when they come I'll give it a really good service, because I don't know how long those belts have been in there. But yeah, the system's working fine. Hopefully you can hear that. So yeah, there you go, guys. I hope you liked this video. If you did, please give it a big thumbs up, like, comment, subscribe, all the usual stuff, and as always, I'll catch you on the next one. Yeah, look at Amstrad CPC. Winner, winner. Catch you next time, guys.